Hello everyone, I'm Autumn, and my group members are Madeline and Andrew. Our project is an intermediate attachment prior to getting a prosthetic, something that is a little more cost-friendly that would help alleviate some of the struggles. Our problem was that when we were doing research, all we could find were similar devices, but only for adults. Children and teens also struggle with bilateral limb differences, amputations, and other injuries that require them to need a little more help. Children and teens who do have these struggles tend to rely on their guardians or siblings more than their peers would. By designing these devices that we're going to talk about, specifically for them, it would help them gain some more independence. It would be child-friendly, small, and portable, as well as offer many different customizations so that the design would be appealing to a younger audience. The first design we created is something that would help mostly in the bathroom. Looking down at the device, there are these prongs that fold in like a telescope to adjust to the item you're trying to put in. These items would be things like a hairbrush, a toothbrush, a loofah on a stick, or even a hair washing helper, and so much more. These prongs would retract with a spring, and the edge of them, where the pink is, would be a gripping material like rubber or silicone. It's shaped like a cone in order to taper at the wrist to fit better. Here you can see that blue space could be a ribbon or Velcro or something else soft that would tighten at the bottom. Lastly, this would be completely customizable by the child, even an option such as white so that they could color on it themselves.
So for the first 3D print design of our project, we modeled a hollow cone with a thickness of about 0.3 inches. The top had a diameter of about 4 inches and the bottom was 3 inches. The entire shell of it was about 4 inches tall too. This was done by sketching a shape, which was a trapezoid cut in half vertically, and then revolving that to form the cone using the revolve option in SolidWorks. Then using the shell feature, we made it hollow. It went to the, oh, never mind. This serves as the main body of the prosthetic, and 4 smaller hollow cones, which were made the same exact way, which are about 1 inch long and 1 inch wide, were made to mount the springs inside for the gripping apparatus. A short cylinder was also made to mount the hollow shell if it was needed for a better fit for the sleeve. We also worked on a second design that I'll hand off to Madeline for.
Okay, so we brainstormed again and came up with this idea. This initial idea was to 3D print the base parts using PLA and construct them separately after completion, and it's modeled after a left hand. There would be hinges between each subsection to allow for movement. So here's a close-up of the joints for each finger. There would be a piece attached, a semi-cylinder with a hole in the middle. So a small metal dowel could serve as the connecting piece. Here's the design before it was printed. Extra pieces were added to allow room for error. Okay, so the top left is a picture of the pieces before they were assembled. I then add a semi-cylinder with a hole in the middle on each subsection of the finger, and then slid the dowel through to create the hinge on each finger. The bottom left picture showcases the completed fingers before they were attached to the base. Ample time was allowed for the pieces to set before continuing on to the next stage. The last 2 pictures showcase the size of the finished product, and the video we're about to present will showcase the hinge mechanism. And here's the finalized product. The pointer finger is fully operational so that lightweight objects may be picked up. The band on top keeps the finger in a stable position, and the bottom band allows so it can be maneuvered so that it sits at a 90-degree angle. The next video we show will showcase the mobility of the final product.
So for the results for the first model, the 3D print was successful and the parts came out really well defined and how they were intended for. This design was intended to be an intermediate stepping stone to the full-on prosthetic so that the transition can be made as easy as possible. And it seems like it would be a little bit less intimidating than the full-on prosthetic. The scaling of our model was a little off. There wasn't enough room to fit the spring attachments inside of the shell and for room for the brush or any other desired attachment to go inside. So we would need to modify the scaling of the design to account for that. And also due to the time constraints from the 3D print, we were unable to implement the spring gripping method we intended on. Throughout the project, we further discussed, and it seems like we could find a better alternative for the spring gripping apparatus as well. And then I'll hand it off to Madelyn.
So for the second model, the 3D printing was also successful. Putting together the pieces was a little time consuming due to the amount of time required for each piece to set properly before going on to the next stage. There was a little difficulty putting all the pieces together. It would have been better if they had been 3D printed together and then only the band or a string would have been the only remaining piece to assemble.
So the future work for the first design would be to implement the spring gripping tool and fine tune that, as well as work on adding the silicone end of the spring to add safety and functionality to the model. Like I said, springs might not be the most user-friendly method of doing this task, so we might have to figure out a better way to solve this problem. The springs might also wear down with over time with extended use as well. A sleeker model should also be pursued to make the design a little bit more user-friendly and allow for younger patients to open up quicker to the thought of using our product. If it's bulky and ugly, our young patients are not going to really want to try it out and make it would make the entire process a little bit more difficult than it already is. And then I'll give it to Madelyn.
Now knowing the extent of the intermediate prototype for the second design, we can conclude that some changes may make the design more appealing. We can implement more hinges, 3 for each finger and 2 for the thumb, so that it accurately represents a left hand, and to also ensure full mobility. A malleable metal rod can be inserted inside each finger so that they are stable when not in use. I will now hand it off to Autumn to explain where to take it from here.
In the beginning, our thought process was to create 2 different designs and then combine the best attributes of both into one final design. However, after talking about it, we realized that they were both very different designs and that we would have issues trying to combine them. However, we did realize that they would be both useful to have. You can use one design after making the necessary adjustments that Andrew talked about, and then we can also use the second design that Madelyn had talked about for different needs like holding the phone or toys. Whatever the uses may be, these both would complement each other and help with a diverse set of tasks. In conclusion, we created a device that would come before a prosthetic. We printed both designs that would be useful for daily tasks, and having both would optimize efficiency. These were designed with children specifically in mind to help them with more independence. These devices are small, portable, and customizable. They are not anywhere near the final design stages. However, making the improvements that we talked about previously would help get us one step closer.